Preparing for a MuleSoft Developer interview? You've reached Candy Mentor, and this video is for you. We'll walk through 15 key questions you're likely to face. For each question, you'll see a sample answer followed by the key points to cover. Subscribe, like, and share, and drop a topic request in the comments. Question 1. What is MuleSoft, and how does Anypoint Platform support API-led connectivity? I describe MuleSoft as an integration platform for connecting applications, data, and devices through APIs. Anypoint Platform supports the full lifecycle: design, build, test, deploy, monitor, and govern. API-led connectivity organizes integrations into system, process, and experience APIs, so teams reuse stable capabilities instead of building point-to-point connections. The result is faster delivery, clearer ownership, and better scalability across cloud and on-premise systems. I also mention governance because reusable APIs need consistent standards. While answering, focus on API-led connectivity, Anypoint Platform lifecycle, reusable APIs, integration patterns, and how MuleSoft differs from point-to-point middleware or simple ETL tools in practice. Question 2. Explain the difference between system APIs, process APIs, and experience APIs. System APIs expose core systems like SAP, Salesforce, or databases with minimal business logic. Process APIs combine and transform data across systems for a business capability, like order fulfillment. Experience APIs tailor that capability for channels such as mobile, web, or partners. In interviews, I stress that this layering reduces coupling, improves reuse, and lets teams change front-end experiences without disturbing back-end integrations. Governance matters because boundaries become contracts. Make sure to cover the 3 API layers: ownership boundaries, reusability, loose coupling, examples for each layer, and why this pattern improves maintainability in enterprise integration programs. Question 3. What is a Mule event, and how are payload, attributes, and variables used? A Mule event is the message moving through a flow. It contains the payload, attributes, variables, and error information. The payload is the main data. Attributes hold metadata like HTTP headers or query parameters. Variables store temporary state within the event. I avoid overusing variables because they can hide flow behavior. Clear payload transformations and scoped variables make debugging and testing much easier in Mule applications. In your answer, talk about Mule event structure, payload, attributes, variables, message immutability ideas, and practical debugging implications when data changes across components within flows. Question 4. What is the difference between a flow, subflow, and private flow in Mule? A flow has its own source, such as HTTP listener or scheduler, so it can start processing independently. A subflow has no source. It is invoked from another flow using flow reference. I use subflows for reusable synchronous logic, like validation or mapping. A private flow can include its own error handling and processing strategy. Choosing correctly keeps applications modular and avoids duplicated integration logic. Be sure to mention entry sources, flow reference, reuse, error handling differences, synchronous execution, and when a subflow is cleaner than copying processors into multiple flows. Question 5. How do you use DataWeave in MuleSoft projects? DataWeave is MuleSoft's transformation language, mainly used in transform message components. I use it to map JSON, XML, CSV, Java objects, and database records into the contract required by the target API. A simple example is mapping payload.customerID to ID and formatting dates with asDate. Strong answers mention functions, modules, null handling, and streaming. The best practice is keeping transformations readable and covered by NUnit tests. While answering, focus on DataWeave syntax, input and output formats, mapping, filtering, functions, null handling, modules, and how transformations support clean API contracts in Mule. Question 6. How does error handling work in Mule 4, especially on error continue versus on error propagate? Error handling in Mule decides whether a failure is swallowed, transformed, retried, or returned to the caller. On error continue handles the error and resumes successfully, often for optional steps or fallback responses. On Error Propagate handles it, but still marks the flow as failed. I also discuss error types, global handlers, custom business errors, and preserving useful diagnostics without leaking sensitive backend details to callers. Make sure to cover Mule error types, try-scope, global versus flow-level handlers, on error continue, on error propagate, retries, logging, and returning meaningful responses. Question 7. When would you use batch processing in MuleSoft, and how does it work? Batch processing is useful when I need to process large data sets asynchronously, such as nightly customer sync or bulk order updates. Mule splits records into phases: input, process records, and on-complete. Each record can succeed or fail independently, and I can aggregate results later. I mentioned batch block size, max failed records, idempotency, and restartability. For real-time request-response APIs, batch is usually the wrong tool. In your answer, talk about batch steps: record-level processing, bulk data use cases, max failed records, aggregation, restartability, and why batch is not ideal for synchronous APIs. Question 8. Compare scatter-gather, choice, for each, and parallel for each routers in Mule. Scatter-gather runs multiple routes in parallel and returns a combined response after all routes finish, so it is great for calling independent services like pricing, inventory, and recommendations. Choice routes to one path based on conditions. For each processes items sequentially, while parallel for each processes collection items concurrently. I always mention error behavior and aggregation because parallelism improves latency, but complicates partial failures and troubleshooting. Be sure to distinguish parallel routing, conditional routing, sequential collection processing, and concurrent collection processing, with attention to latency, ordering, aggregation, error behavior, and trade-offs. Question 9. What is APIKit, and how does it help with RAML or OpenAPI-based development? APIKit turns an API specification into an implementation scaffold. I usually start with RAML or OpenAPI, generate flows, and let APIKit route requests based on resources and methods. It also validates request structure, parameters, and content types against the contract. This supports contract-first development, where consumers review the API before back-end logic exists. In interviews, I connect APIKit to mocking, documentation, versioning, and API manager governance. While answering, focus on contract-first design, RAML or OpenAPI, generated routes, request validation, mocking, documentation, versioning, and how APIKit accelerates implementation in Mule projects safely. Question 10. How do you configure connectors and manage sensitive properties in Mule applications? Connector configurations should be centralized and reusable, not duplicated inside every flow. I externalize URLs, credentials, timeouts, and reconnection settings using property files and secure properties. For secrets, I avoid hardcoding and use encrypted secure configuration or a vault-backed approach when available. Good connector design includes connection pooling, sensible timeouts, and clear error mapping. That makes applications portable across dev, test, and production environments safely. Make sure to cover connector configuration reuse, secure properties, environment-specific configuration, connection pooling, timeouts, reconnection, secret management, and avoiding hard-coded credentials in deployable applications always. Question 11. How would you choose between CloudHub, Runtime Fabric, and on-premise Mule runtimes? CloudHub is MuleSoft's managed iPaaS runtime, simple for deploying workers with built-in monitoring, scaling, and load balancing. Runtime Fabric runs Mule workloads on Kubernetes or customer-managed infrastructure, useful when teams need network control, hybrid deployment, or compliance boundaries. On-premise runtime gives maximum control but more operational burden. I choose based on latency, data residency, connectivity, cost, and who owns patching, scaling, certificates, and runtime reliability. In your answer, compare CloudHub, Runtime Fabric, and on-premise runtimes using criteria like operations, scalability, networking, compliance, hybrid connectivity, cost, and ownership of runtime reliability responsibilities. Question 12. How do you secure APIs in MuleSoft using API Manager, and implementation-level controls. I secure Mule APIs at multiple layers. In API Manager, I apply policies like Client ID enforcement, OAuth 2.0, JWT validation, rate limiting, spike control, and IP allow lists. At the implementation layer, I validate input, avoid logging secrets, and propagate correlation IDs for auditability. Strong answers separate authentication, authorization, transport security, and governance. Policies are powerful because they protect APIs consistently without changing application code. Be sure to mention API Manager policies, OAuth, JWT, Client ID enforcement, rate limiting, TLS, validation, secrets handling, and separation of authentication and authorization clearly. Question 13. How do you design reliable Mule integrations when downstream systems are unstable? Reliable integrations assume networks fail, services time out, and messages can be duplicated. I configure connector reconnection for transient connectivity issues and use until successful when a processing step should retry with a controlled scope. For non-idempotent operations, I add idempotency keys, duplicate checks, or transactional boundaries. I also set realistic timeouts and dead letter paths. Retrying blindly can amplify outages, so backoff and observability matter. While answering, focus on retries, reconnection strategies, until successful, timeout design, idempotency, dead letter handling, transactional considerations, correlation IDs, and avoiding retry storms in integrations production. Question 14. How would you troubleshoot a slow Mule API in production? I start performance tuning with evidence, not guesses. I check response times, CPU, memory, thread usage, connector latency, payload sizes, and external dependency performance. Common fixes include streaming large payloads, avoiding unnecessary transformations, tuning connection pools, reducing chatty calls, and using caching where safe. I also review logs and Anypoint monitoring traces. Many Mule bottlenecks are downstream systems or poor API design, not the runtime itself. Make sure to cover Anypoint monitoring, logs, metrics, payload size, streaming, connection pools, thread usage, downstream latency, caching, and evidence-based tuning for Mule APIs effectively. Question 15. How do you implement testing and CI/CD for MuleSoft applications? A solid CI/CD pipeline builds, tests, packages, scans, and deploys Mule applications consistently. I use Maven with Mule Maven plugin for packaging and deployments, munit for unit and flow tests, and environment-specific properties for configuration. Tests should mock external systems and assert payloads, variables, attributes, and error behavior. I also include API spec validation and automated promotion across environments. This reduces release risk and catches broken transformations early. In your answer, talk about Maven, Mule Maven plugin, munit, mocking external systems, automated deployments, environment properties, quality gates, and promotion across environments in enterprise CI/CD pipelines. If you are still with us, congratulations. You are much ahead of the rest and serious about preparing for your interview. We hope we were able to add value to your preparation and create some helpful content. Do not forget to like and share this video. Your small act can do great things for us.